Good afternoon to all the participants that have joined so far. Let's wait for another 5 minutes to see if more are joining, because I see you still have people joining in this moment. So let's give it another 5 minutes and then we can start. Okay, I see that people are joining at a much lower pace now, so if you all agree, I think we can start. Good afternoon, everyone. My name is Alessandro Cristofori, Support Officer in GeoSolutions. Thank you very much for joining us this afternoon. Today we are here to talk about mostly GeoNode and how is used in Unique Land Use. But before giving the word to Unique Land Use, I will begin with a short introduction to GeoSolutions, who we are, what we do, and how we help organizations to manage and share geospatial data. I also give you an overview of GeoNode, which is our open source platform for publishing and using geospatial information. And after my introduction, I'll hand it over to Katia and Angelo that will go much more in detail in explaining how GeoNode has been successfully adopted by Unique Land Use. GeoSolutions is a leader in open source geospatial technologies. We were founded in 2006, and today we operate internationally with offices in Italy and United States. A defining aspect of our work is our full commitment to open standards from the Open Geospatial Consortium, OGC. Our portfolio includes several key open source products. As you can see here, we have GeoServer, one of the most widely used servers for sharing and editing geospatial data. We have map stores that allows users to create modern interactive mapping applications and dashboards directly in the browser. Then we have GeoNode, our collaborative platform for publishing, managing, and sharing data and maps. This will be the main focus of today's presentation. And to support all these technologies, GeoSolutions also provides enterprise services such as long-term support, deployment subscriptions, tailored solutions, and professional training. So we help organizations successfully adopt and scale open source geospatial software. GeoSolutions is trusted by more than 335 clients worldwide. As you can see from these slides, our clients are from a wide range of sectors, international organizations, government agencies, research institutions, private industries such as insurance, energy. So to give you some examples, we support DLR, the German Aerospace Center, EUMETSAT, the European Meteorological Satellites Agency. We are partnered with EMSA, the European Maritime Safety Agency. We cooperate with a lot of public administrations, a lot of governments, such as Comune di Genoa, Genoa Municipality, Natural Resources Canada, City of New York, City of Florence. And as I said earlier, we are also quite active in the energy sector. So we are partnered with Total Energies, Alibaba, and GEC. So going a bit into details of our domains of expertise. So EUMETSAT, NOAA, Radar Meteo, TWD, Climavisions, Consortium. These are all agencies that deal with climate data. We provide for them a platform for visualizing and distributing satellite-based meteorological data. We help them handle large volumes of satellite and observational data, for example, the case with NOAA. For example, Climavisions, we help them deliver real-time data coming from radar networks. And for DWD, Deutsche Wetterdienst, we enable advanced geospatial platforms for weather and climate data, for example, for forecasting risks, map risks, and for public government authorities. We are quite active in the Earth observation value chain. So, as I said earlier, ELR with the Earth Observation Center, MAXA, and Veridian. These are all partners that we help in order for them to deliver and visualize high-resolution satellite imagery. So, also satellite imagery data. And again, in the energy sector, our technology supports oil, gas, and renewables. Companies like Alibatum, Total Energies, and Mapstent use our tools to manage and analyze complex spatial data, whether it's for offshore exploration, pipeline mapping, renewable site planning, and so on. Now, the sector that our technologies are quite big into is precision farming. So in the slides, we can see examples of diagram, which is a University of Pisa entity for the studies of crop maps and soil information. We provide mapping application supporting smarter irrigation, fertilization, zero forecasting, and we also operate more at the commercial level, like, for example, Farmer's Edge, in which we also provide maps for the handheld devices. For public administrations, for example, Grand Metropole, that uses our tool for urban management and citizen services. City of Genoa used a lot of our 3D tools in Map Store for planning and infrastructure and monitoring. Cleveland Metro Parks uses our technologies to manage natural assets and share information with the public. We also support Craig in France for the management of cadastral and land registry data. City of Florence, which has lots of historic buildings in its urban settlement. We manage them to this complex urban environment. We manage to support them. And finally, for example, for Vlaanderen, which is the MOW, we help them visualizing map related to transports. Is the Department of Transport for the region, the Belgian region of Vlaanderen. The success behind is due to our top-notch team. We operate with offices in Italy and US, as I said earlier, but our reach is global. We are more than 40 staff members, and including 30 highly skilled softwares. What really sets us apart is the fact that we don't just provide solutions, it's offer consultancy, but the people working in your solutions are at the front scene for as long as, designing and guiding open source software into special industries concerned. So our developers actively participated and lead the development of the main open source softwares, GeoNode, GeoServe, Store, and GeoNetwork. And at the same time, most of our developers are also certified developer in CESU, which also includes 3D data. So we don't just understand the software inside out, but we also shape it to meet the evolving needs of the geospatial community in open source. Now, let's talk about GeoNode. So what is GeoNode? GeoNode is our platform for managing and sharing geospatial data. It combines mature open source components and into one easy to use environment. The power of GeoNode is that people that are not experienced in the open geospatial software can share and build maps with not just maps, but build geospatial resources with their own data. In a few words, it lowers the entry barrier and makes geospatial information accessible to a much broader community. Very briefly, GeoNode is not just the data repositories, it handles and mixes different types of data, not just geospatial data set, but also documents and media. Has a strong management features, so it has an authorization model that would allow admins to allow granting permission to see, edit, and operate with the data stored in GeoNode. GeoNode supports data editing, and most importantly, GeoNode does all of this down the umbrella of the OGC services. So we'll talk about WMS, WFS, WCS, and also metadata. He offers also a quite big metadata engine behind the scenes. Not to last but not least, also GeoNode has a quite strong RESTful API that would allow developers to build other applications in GeoNode. Here we explain what GeoNode is flexible to give us when it comes to other data. You can start from local files, you can upload through a computer, you're not limited to local resources, GeoNode can connect to remote services, or other OGC services, which is WMS, another GeoNode, ArcGIS server, at least, and as well custom artists that pulls data automatically. So one practical example I can show you, the use of GeoNode is the Po Basin Authority. As you can see here, this is their GeoNode that they use to load the DTM data. This is, for example, very simple yet powerful explanatory map of how it's possible to load data from various sources and display them in GeoNode, and how it's possible to easy to ingest the data. GeoNode offers quite an advanced visual styling. As you can see in these examples, the user can combine predefined markers to add text. They can create informative layers, also not limited to presets. GeoNode allows full customization of styles using CSS and SLD, giving the complete control to the user about how data is represented. Users can tailor the visual language of their maps with much more flexibility. As I said earlier, an important feature of GeoServe is the ability to have an authorization model behind it. So we have got different roles that would allow different user or other admins to see and edit or do operations with the data. It's all possible to do within the GeoNode application. GeoNode has a quite big metadata engine behind it, all operated within the OGC standards, so under the CSW protocol, and as well is powered by PyCSW, which means that is a library in Python that can also be implemented and developed on GeoNode. Once data and documents are inside GeoNode, the real value comes from how they can be mined. So strong in loading data, strong in visualizing, but it's not just possible to create maps. In GeoNode, you can create data sets, reports, media. You can build interactive maps, create your stories that combine maps with narrative and multimedia to tell the story behind the data. You can design dashboards that bring together multiple indicators for monitoring and decision making. And you can also build other GeoApps on top of GeoNode itself. And this is, for example, the last example that I mentioned. So this is the case of MapStand. We developed a customized geographic information based on GeoNode. This is a GeoApp that stands out altogether. The client operates in oil and gas exploration sector and had very specific requirements for data investigation and analysis. What's interesting here is the positive synergy. Not only GeoNode is integrated, but it's also extended through the customization of services we provide at GeoSolutions. So this is basically another GeoApp, heavily tailored for the clients, built on top of GeoNode with enriched and additional features that go behind the standard platform. So here we have another example of data visualizations, which are dashboards. Show you this one, for example. So this is a dashboard created by the by the University of Pisa for the studies of the hydrogeological impact of anthropization in the region of Massa. In here, you can see we don't just combine mapping data, but we also have the attributes of the data that are shown to create charts, that are shown to create table. So they give another and more, say, complete insight about the data they want to represent. Then we have GeoStories, as I said earlier. Just bring it up. This is an example we have. Public example, we have the city of Oeiras. I can click it here. So as you can see, using GeoStories helps to create compelling visualizations of data that don't just have the map as a focus. Yes, we have the map, but we also see that we can combine pictures, we can combine text, we can animate the map, can combine, say, different type of maps, static maps together, different type of layers and dynamic maps, charts as well. So this is more, to give another perspective of the data and let you tell the story. What's the story behind not just the map, but behind location, behind what's behind the geography of a place or of an event. For example, of the powerful 3D data that we have in GeoNode is the city of Stuttgart that uses 3D tiles and GeoNode to load 3D data for the representation of the city. As we all know, 3D has become quite a widely used tool in most of public administrations, and GeoNode offers right off the shelf the ability to load and display 3D tiles data with no further development. As I said, one of the biggest powerful characteristics of GeoNode is the ability to basically combine all the resources shown so far and deliver and disseminate them using geospatial technologies and widely used technologies such as OGC. There's open source standards. It offers a REST API and HTML5, so it's also easy to connect and create an interface to GeoNode. And finally, this will be delivered for you in the presentations. If you want to take a closer look of code of GeoNode, how GeoNode would look like, uh, you can find us at these links. Right. So thank you very much for your time. I'll hand it over to Angelo and Katia, which will go much more into detail about how they found GeoNode and how it helped Unique Land Use in their activity. Thank you. Over to you.
Thank you, Alessandro, for that great introduction. Let me just go ahead and share my screen. So, there we go. So my name is Katja Weilmüller, and I'm a geospatial consultant for Unique Land Use. And Angelo and I are going to walk you through how GeoNode supports the project work of the Geospatial Solutions team of Unique Land Use. So I'll give you a little bit of an introduction to Unique as a company and the kinds of projects we work on, and then specifically to our digital solutions department. Then we will go through a few of our projects and show you some GeoNode usage and practice, and then we'll conclude the presentation with a Q&A section. So first to the introduction. We are a consulting firm specializing in intelligent land use strategies around the globe. To accomplish that, we partner with public and private organizations, with governments and communities to create an inclusive and sustainable future for all. We have 4 technical departments. First, our digital solutions team, more on that in a second. Then we have the agriculture and rural developments team, focusing on sustainable management of agricultural land, forests, and other natural resources by creating, for example, climate-smart land use and livestock systems, food systems to ensure food security and a balanced diet, or participatory land use planning and rural development. Our forestry department is working on forest inventories, forest management, and value chains for forest products, while our climate team works mainly on carbon projects to create carbon credits for the voluntary carbon market. In the more than 25 years of company history, Unique worked on over 1,000 projects for more than 600 satisfied customers in over 70 countries. We worked on more than 20,000 hectares of FSC certified forests, and as of currently employ more than 80 in-house experts in their respective fields. We have sister companies both in Paraguay and Vietnam, and we have offices in South America, Africa, Europe, and Asia. Our know-how is in demand worldwide from a broad variety of clients. As you can see, we work with development banks, multilateral organizations, investment funds, ministries, municipalities, associations, as well as many organizations within the private sector. And now to the introduction of our digital solutions department. That is our specialist department for developing digital tools for the wide range of projects that we work on, which includes data analytics, geospatial solutions, which specifically works with remote sensing data, and also digital monitoring and reporting systems, with one of our teams focusing on the MIS side and the other team focusing on geospatial analysis. So starting with the MIS, which again stands for Monitoring and Information Systems, there we support with our in-house app to collect data in the field, analyze that data, and then monitor and report on that data during the whole of the project cycle. We support projects for all of our core departments by collecting data from external sources, from our app and our web dashboard, and then provide reporting and management tools to our clients. As an example, one such project type are the smallholder carbon projects, where often tens of thousands of farmers take part in a project, and the data collection app can be used by them on the ground to enter their data, allowing us to manage these huge projects, evaluate each contribution, and calculate the stored carbon over the years. Other project types would, for example, include forest inventory, greenhouse gas emissions for livestock, and everything where we are doing data collection. And then we have, of course, our geospatial solutions team. We also work on a wide range of projects here. For example, project design that has to do with Earth observation data, such as feasibility and eligibility assessments, for example, for carbon projects, but not exclusively. We also do similarity measurements, improved forest management, etc. Then we have monitoring, reporting, and verification, where we are doing deforestation and degradation analysis, damage detection, land cover change detection, statistical analysis, and all of these types. Then we also have carbon stocks and biomass analysis, where we are working with LiDAR, for example, or other types of data to assess forest biomass. And then we have a range of geospatial tools for processing and visualizing. A very important one of those is GeoNode, of course. And with that, I would like to hand over to Angelo to go over a few of our example projects.
Yeah, thank you, Katja. Then let me share my screen. Can you see my screen?
Not yet. There we go.
Great. Yeah, now that you have a clear overview of our company and the department, I'd like to take you through some of our highlighted project first. These examples will showcase not only the scope of our work, but also the impact our team is delivering. Yeah, first, let's look at our forest carbon baseline assessment project type. The primary objective here was to establish accurate carbon stocks in restoration sites, essentially creating a foundation for measuring carbon sequestration potential. Our digital solutions team is taking the lead there on remote sensing data analysis and developed carbon modeling system, created an intuitive digital reporting dashboard that makes complex carbon data accessible to stakeholders. Moving to our eligibility assessments. This project is addressing a critical need in the climate finance sector, determining which project sites or proposals qualify for climate finance or carbon project registration. Our role there was to develop and implement digital tools that streamline their entire process. These tools collect, validate, analyze eligibility data, but incorporating everything as well, from remote sensing suitability analysis to land tenure verification and baseline land use assessment. Our third highlighted project focuses on individual tree segmentation and species classification. There, our objective is to precisely identify, segment, and classify individual trees using remote sensing imagery on the one hand and LiDAR data on the other hand. And our team applied their geospatial analysis combined with machine learning algorithms to automatically segment tree grounds and classify species. And finally, our forest risk assessments. Here we are tackling the challenge of identifying and mapping forest deforestation risk zones before damage occurs. Our team leveraged geospatial risk mapping techniques, combining remote sensing data with machine learning to create predictive models that help to protect our forest proactively. Yeah, now let's dive a little bit deeper into our eligibility and feasibility assessment. Yeah, our assessment process includes different critical components that ensure through project evaluation, we analyze wetlands, peatlands, organic soils. Yeah, these are all crucial carbon-rich ecosystems that require special consideration in any climate project. We utilize as well soil vector data to understand the soil composition and carbon storage potential of the project area. And we examine ecoregion and forest cover patterns. Our analysis incorporates data from, for example, Global Forest Watch and Pulsar, as well as ESA World Cover and Dynamic World. This multi-source approach ensures we capture the most accurate and up-to-date forest coverage information. We conduct deforestation analysis covering the last 10 years. Prior to the project initiation. Yeah, this historical perspective is essential for establishing credible baselines and understanding deforestation trends, for example. The maps you see here on the right demonstrate our work in Paraguay. Yeah, where we managed forest and non-forest areas using 4 different methodologies. So on the right, you can see our detailed analysis of forest loss, wetlands, and organic soils with temporal data showing deforestation patterns from 2013 until 2022. And yeah, the color-coded legend shows how we track forest loss over time, and as well water surface occurrence and different soil types. This level of detailed analysis allows us to provide both market standard assessment, but as well premium highly detailed evaluations depending on the project requirements and the accuracy, of course, which is needed. Let's move on to our deforestation risk mapping, which represents a proactive approach to forest conservation. So the purpose of this tool is to highlight statistical clusters of forest loss across regions, enabling stakeholders to identify high-risk areas before the significant deforestation occurs. What makes this particularly valuable is our rapid delivery time frame. So we can complete a risk assessment analysis in just 10 days, plus, for example, an additional 5 days to deploy it as a fully functional Google Earth Engine map app, for example. And yeah, this app making this analytics accessible through an intuitive web interface. As you can see on the screen, yeah, this is our risk analysis application in action. The app provides 2 types of analysis, preliminary analysis aggregated by district, for example, here using Hansen Global Forest data, and the final analysis that combines multiple data sources, including dynamic world, for example, or the tropical tree cover dataset, and as well Sentinel-2 imagery. Yeah, the interface shows our work across multiple countries here. We can see Zambia, Senegal, and other regions. The color-coded risk mapping uses a clear system. So green indicates low risk areas, yellow shows medium risk, and red highlights very high risk zones. Yeah, and on the right panel, you can see a detailed analytics for specific districts. And yeah, this provides comprehensive data, including forest cover percentages, risk classifications, and agricultural drivers, for example. This level of detail allows project developers and conservation organizations to make data-driven decisions about where to focus their efforts and resources for a maximum impact. Next topic is a little bit more into our LiDAR insights. So the proposal here is to design and establish mixed terrestrial and LiDAR-based forest inventories that improve annual forest assessments. So we operate here through two integrated pipelines. One is our segmentation pipeline, which segments the LiDAR point clouds into individual trees, extracts canopy height models and digital terrain models, and identifies tree tops, calculates forest metrics, and performs at the end a precise single tree segmentation. And our second pipeline is the classification pipeline, which is using a random forest classification trained with, of course, reference felt data and combining their RGB images with LiDAR metrics to automatically classify tree crowns identified by our segmentation pipeline before. We have here as well an example from our sister company, Unique Wood in Paraguay. This project demonstrates our collaboration between our forestry department and our digital solution department to first design and establish a mixed terrestrial and LiDAR-based forest inventory. The goal was here to enhance the efficiency and precision of annual forest assessments we do there for our managed forests in Paraguay. Our contribution to this project included establishing permanent terrestrial sample plots as reference data for the allometric functions and URV-based LiDAR and RGB data capturing and providing ground truth data for validation. Our role focused on single tree segmentation in eucalyptus plantation stands and deriving stand attributes, including the height, diameter at breast height, ground size, ground cover, and so on. But as well at the end, biomass and carbon calculations. Here at the top image, this is showing our canopy height model with individual tree segments clearly identified. And the bottom cross-sectional view provides a side profile of the forest canopy of the point cloud. And this level of detail at the end with the whole forest metrics and the single tree stands enables the forest managers to optimize the harvesting schedules, but as well monitoring growth rates and accurately calculate carbon sequestration. Which is basically our goal is transforming those forest management from estimation-based to precision-based operations. We had a very interesting project in Germany, which is called Digital Detect. It's representing an innovative approach to forest health monitoring, specifically targeting bark beetle infestations through satellite-based detection systems. The phase one of this project was commissioned by the Ministry of Forestry of the state Baden-Württemberg in Germany and is addressing a very critical challenge here. So the German forests are under severe threat from bark beetles, exacerbated by storms, extreme droughts, and high heat as well. So traditional terrestrial control surveys are very expensive, time-consuming, and often too late for effective intervention. So our solution leverages satellite imagery to detect early stage infestations and enabling then a rapid response. The project targets infestation detection in cooperation with the partner in Freiburg here, mapping infested spots in 7 to 14 days cycles using daily available satellite imagery. Our contribution there includes several key innovations. We developed a satellite image-based detection of vitality changes in coniferous forest, and fully automated the processing chain for scalability. We provide as well bark beetle warning maps to forest owners at regular intervals throughout the summer season, enabling then for that proactive forest management. And our next project is an AI degradation approach that serves three critical purposes. First, we assess whether forest management interventions have successfully reduced degradation rates on coffee plots managed by partnering farmers. Second, we evaluate long-term forest degradation trends across landscapes. And third, we quantify biomass changes across areas of interest and estimate their carbon emissions. As you can see in our neural network diagram, we input data through multiple hidden layers that learn complex relationships between satellite imagery and actual biomass measurements, producing then accurate output predictions. The satellite imagery on the right demonstrates our results. These maps show the biomass decrease and increase between different years across the same area. The color variations reveal where forests are recovering, remaining stable, or experiencing degradation. For example, in the top image, you can see areas of significant biomass change indicated by the reddish tones. And while the bottom image shows different temporal patterns with blue areas indicating biomass recovery or growth. Then let me present our work on Earth observation information product development for the agricultural sector. It's a global initiative with the European Space Agency that demonstrates our impact on sustainable agriculture worldwide. This project operates under the joint initiatives Space in support of international development assistance, a collaboration between the ESA, World Bank, and the Asian Development Bank. It showcases the range of application examples for Earth observation in agricultural investments projects globally. Our contribution there spans two critical areas of sustainable agriculture. First, we addressing methane emissions reduction from rice cultivation in Indonesia. There we're using Earth observation-based analysis. We examine different rice cultivation methods and their greenhouse gas emissions, specifically methane output. Our work focuses on identifying and scaling GHG-reducing cultivation methods that can be implemented across Indonesia's rice growing regions here. And the second step, we are working on ecosystem services, appreciation and protection against climate change and biodiversity loss through our Earth observation project for example, here in Guyana. This involves comprehensive sustainable agriculture and forestry policy assessment, where we use satellite data to inform policy decisions. And additionally, we conducting classification of areas usable for agriculture under the European Union deforestation regulation, ensuring that agricultural expansion doesn't contribute to deforestation. And The next and last project type I will present to you is the verified carbon standard certification. Here presented by a project in Zambia, which demonstrates our end-to-end capabilities in carbon project development. So this project, commissioned by a personal investor, represents a comprehensive biomass inventorying following the VERA standards, the gold standard, and the carbon credit verification. Our approach involves 3 integrated phases. The first phase, the inventory design, is where our digital solutions team handles the technical foundation. So we are creating forest masks, verifying forest areas, developing sample plot grids, and selecting fieldwork and sample plots. And our team developed a custom data collection app to ensure accurate and standardized field data capture. The second phase, the field campaign support, is where we provide comprehensive data, not data training, sorry, and our monitoring and information system team trains the field teams on app usage, while our carbon department conducts the field measurement training, ensuring data quality and consistency. And the third phase is the post-processing, where both our team and the carbon department collaborate on forest biomass calculation that meets the VERA's stringent requirements. Now let me introduce to you a little bit GeoNode in practice, how we use GeoNode. It's more on the practical management side, because Alessandro showed you a little bit capabilities GeoNode have. I will give you a little bit more on the view on the management of users and of data sets and documents. What you see on here is our GeoNode interface, which serves for us a centralized hub for all of our geospatial resources. Currently, the platform hosts hundreds of our data sets, and demonstrating the extensive data repository we have built over the last couple of months. The interface is organized into clear sections, data sets, maps, documents, geostories, and dashboard. Alessandro showed you a little bit before these ones in detail. This is providing us multiple ways to access and interact with those geospatial informations. As you can see from this gallery view, our GeoNode contains diverse geospatial datasets from projects around the world. And from forest cover analysis to risk assessments, from individual country studies to regional comparative analysis. Each resource is contributed by, or can be contributed by, our employees. And this is fostering collaboration and knowledge sharing across our organization, which helps us a lot. The platform enables users to view, analyze, and download geospatial data, and create custom maps and build interactive dashboards. This democratizes access to complex geospatial data analysis and allowing our colleagues and stakeholders to explore the data independently. GeoNode serves as a backbone of our digital solutions, ensuring all our projects outputs from deforestation risk maps to LiDAR analysis results are accessible, shareable, and actionable. But a very critical component for us and for our GeoNode platform is the comprehensive metadata management, which ensures the data quality, traceability, and compliance with international standards. So what you see here, for example, is our metadata entry interface for Global Mangrove Watch. For example, here, Global Mangrove Watch 2020 data, which is really accessible in the World Wide Web. But for us, it's very important as well to have those global data sets in GeoNode that we don't have to search again and again for the same data sets, and our colleagues can just download them and seeing all of the information of Global Mangrove Watch as well here, for example, in the abstract or in the free text keywords and so on. Basically, the metadata management follows a structured four-step process. So the basic metadata, the location and licenses, the optional data, and the dataset attributes. In our company, it's very important that we completely fill in, for example, the basic metadata and the location and licenses, which should be mandatory, but the optional ones are not that important. It's as well time consuming, but as I mentioned before, it's ensuring the data quality. The metadata management includes essential elements like, for example, the data source attribution, the responsible persons, contact information, and as well detailed descriptions like the abstract. But very important for us is as well, for example, the host, sender, and group, which you can see here, which helps us to assign data sets to a specific project, for example, or to a specific persons. And it allows us to have a better and more specific user and data management. We specify as well different roles for different types of user to control access to those data sets and documents and projects. By maintaining these metadata standards, we enable our colleagues and stakeholders to understand their data origin, assess data quality, and of course, make informed decisions about data set applicability for their specific needs. What's as well a very important button or tool for us is the linked resources capability, because that's very crucial in data management. For example, here you see again the global forest mangrove data set, and displayed here in an interactive map. But the linked resource is in the right panel. This feature allows us to establish connections between related data sets. So it makes GeoNode like a web of interconnected geospatial information, if we can say so. So we can link, for example, now this data set to related data sets like the metadata document or even to other years, for example. This linking system is essential for comprehensive environmental analysis in our case, because our project and, for example, the ecosystem worldwide don't exist in isolation. So mangrove data can be connected to forest data, which can be connected to carbon data, and which be can connected to biodiversity assessments. This feature allows us to discover related data sets automatically, ensuring they have access to all relevant information for the analysis. And instead of searching separately for each data set, users can just follow the data relationships we have established. And as I mentioned before, let me show you a little bit our user management system, which is essential for secure data sharing and collaboration. What you see here is the sharing interface, the basic sharing interface where we can control access to data sets. The dialog shows options to share with specific individuals or groups, ensuring data security while enabling collaboration. So our user management system operates basically on multiple levels. We can share data sets with registered members, specific groups, or make them publicly available. So providing flexible access control based on data sensitivity and project requirements. In this example, you can see we are managing access for various project-specific data sets, including projects in Ukraine, Vietnam, Laos, or Mozambique, for example. And each group and each data sets can have different permission levels and user groups. So the system or this system allows us to create project-specific user groups, enabling seamless collaboration within teams while maintaining data security. For instance, we can create groups for specific climate projects or for specific forest monitoring projects. Users can have then different permission levels, so from view-only access to full editing rights, ensuring that sensitive data remains protected while still enabling productive collaboration. Yeah, so basically, main message here is that our user management system ensures that the right people have access to the right time and to the right data. Yeah, to conclude, let me summarize a little bit the key strengths of our GeoNode platform and our roadmap for future improvements. Our GeoNode platform delivers several core strengths that set us apart. We support the GeoNode platform support multiple data formats for seamless data integration, coupled with comprehensive data and metadata management that ensures data quality and traceability. Our user and project management system operates on permission-based access with customized metadata fields, enabling secret collaboration while maintaining, of course, data integrity. The platforms access at linking data sets and documents, creating interconnected knowledge network, while of course advanced search filters like the keywords tagging make data discovering intuitive and efficient. Yeah, and most importantly, GeoNode is forcing collaboration and knowledge sharing on geospatial data across our organization and of course with external partners if necessary. And it provides multiple ways to access, share, and make data actionable through different sections like maps, geostories, and dashboards. Additionally, there is a QGIS plugin available, which is enabling seamless integration with desktop geoinformation system workflows. Looking ahead, we want to focus on key improvements where we are in discussions and contact with GeoSolutions. For our case, it would be nice to explore or to have integration possibilities for point cloud formats to better support LiDAR workflows. There's a plan as well to strengthen the QGIS plugin and expand its functionality to make data editing faster and more intuitive in our project cycles. And finally, a refresh button for datasets and documents, I think will be included in one of the next upcoming versions. Ensuring users always have access to the most current data, of course. Then thank you everyone for your attention. Now we are happy to answer any questions you may have, and now in our Q&A session. Thank you.
Okay, so if you all agree, I can read the questions and you can answer. If I can answer, I will answer, depending on towards which these questions are addressed. So we have a question for Patrice, from Patrice. He asks, what authentication security backend are you using?
That would be now a good question for our developer, which is in contact for you. I think it's the let me check. Or Michelle is as well here. Maybe she can answer.
In any case, I can answer.
You can answer as well because
in a general way. So Of course, GeoNode allows different authentication providers, username and password through the Django authentication model, because GeoNode is based on that. But it's also possible to plug in the open OIDC protocols authenticators, which makes it pluggable, for example, to Azure, and makes it that's another authenticator which is possible to plug in onto GeoNode. In the Unique Land Use specific case, I think you're using Azure, maybe, or you know, sometimes I did some support for them. So
No, sorry, I can't answer right now.
well, OpenID Connect, whichever providers would offer an OpenID Connect standard, like Microsoft, as I said, Azure, and Google, it is possible to use them in GeoNode. And it also, of course, offers the single sign-on possibility. GeoNode can plug in that. Brad, is your instance of GeoNode available to the public?
No, it's not. It's just for us or for partners. So yeah, if we have basically we use it in our own organization, but for partners and of course for clients we offer options to access or to store project specific data there, but it's not open for public.
Donald, do you implement any auditing for your edits or allow rollback actions?
Not yet. I mean, we have versionings of our data, but that happens that we just archiving the old ones and upload the new ones. Basically, but GeoNode should just show always the most current data in our projects and the data which is used in our projects. If this answers your questions. I think so. I hope so.
Right. So I had posed this question to ChatGPT.
Okay.
Does GeoNode support display data of using PBF or something similar as in the case of GIS Online? Yes, GeoNode through GeoServer plus Maps.2 supports vector tiles, but it's not enabled by default. You need to install the GeoServer vector tiles extension. So it's a very long question. I read it beforehand. So Sindile, I have a link I can send you. I can share it to the chat that would explain how to install the vector tiles extensions for GeoServer. So GeoNode and GeoNode has inside itself Mapstore, but it is not a data server itself. It is just a tool for displaying data. So if you need to have or serve data with vector tiles format, this is something you need to, let's say, set in GeoServer. And GeoServer is, of course, parts of Mapstore. So I'm going to share with you in the chat two links. One that would explain how to install the GeoServer extension for vector tiles. And another one that will explain more in detail what GeoServer does with vector tiles and how they are managed in GeoServer, of course. Once you are there, yeah, you can serve that to GeoNode and you can consume data into GeoNode. But GeoNode is not a tool basically to serve data. That for that it's GeoServer, of course. So which are the dataset types you can add to GeoNode? Okay, so maybe we should go back to my part of the presentation where that part was explained, or I can show you a demo. So to start with, GeoNode uses GeoNode can consume any service that comes from the OGC standards. So that can be considered a type of data? Well, it's not. Let's say it's a standard to serve geographical data. So if you need WMS to serve raster data, then you use WMS. If you need to serve vector data, then you use WFS. Tiled data, WMTS, or tiled WMS. And that is one type of data that is possible to add. I know that it's possible to add other types of documents as well. I'm not sure what let's share my screen so I can show you. Supported file extensions are SV shape files, CSV, GeoPackage, GeoJSON, KML, KMZ, 3D tiles, GeoTIFF, zip archives, XML metadata, file, styled NSLD, style layer descriptions. This is just to give you an idea of the type of data that is possible, the type of data sets that is possible to add onto GeoNode. Are you aware, Angelo, of any other format you use in your use case that it's worth mentioning?
Regarding data sets, mostly GeoTIFFs, SV shape files, CSV. Yeah, what's yeah, GeoTIFF is there, yeah, right. Yeah, and zip as well a lot. So like every data set type which was listed there. So
okay. I think that this for the moment should answer.
But of course you have the different document type formats, right?
Yeah, if you can help me with that. Do you know if we have? Ah, there you go.
Yeah, there you go.
A lot of formats. So
yes.
I'm not listing all of these, but as you can see, text, the CSV, log, video, and tag, and so on. These are the types of data sets possible to add to GeoNode. And of course, adding a data set will also means that it's possible to add a remote service. As I said earlier, this is not static data. These come from external services that publish their data with OGC standards, WMS in this example. So that is another data source that is possible to add and use GeoNode service as well. So again, this instance of GeoNode is public for those who asked if there is a public instance of GeoNode. Yes, we have it. This is the demo one. It also is published in the slides. There are links in the slide. So you can create your own accounts, local accounts. That will be just the user one. You have just limited access. And you can take a look and see the demo of a working version of GeoNode. So I don't see at the moment any other question. No. Can you add secured WMS and WFS? I don't think it is possible to do it, but I know that this feature has been implemented lately in Mapstone. Secured, it means that, of course, let's make the distinct. Let's make the. If you're talking about WMS and WFS services secured and backed by the GeoServer from which you are serving the data to GeoNode, the answer is yes. If you're talking about external services that are secured, I need to double check that, but we'll give you an answer. But that's for sure, it is possible to do it with the GeoServer that is associated with the GeoNode itself. Because of course, GeoNode has its own authorization and authentication model that also cascades on the data that you would source from GeoServer. So if there is a GeoServer, the answer is yes. Then we have another question in the chat. Does GeoNode support the customization of land use model, considering that different countries such as Ethiopia may have unique land use classification and standards? Well, I think it does. As far as I've understood from this question, that is probably something that pertains more to how you shape the data rather than how you, the tools that you use to display it. So I would imagine that you have classification of model classifications for land use that you will use in your country. And as long as it is classified and stored on GeoServer or any other service that would serve a WMS server, GeoNode would be able to read it and display it. What the customization of land use models? GeoServer isn't GeoNode isn't really able to edit a model itself. I'm not sure which level of customization you are referring, but it doesn't really offer those capabilities. No, it's not really clear what customization of land use models. Maybe I'm not sure, Angelo, if you know what does.
To be honest, I don't understand the questions exactly. So if you're speaking from adjustment of models you have, then GeoNode is not like a tool like Python or something like that. It's more like visualizing and management of data sets and dashboards and so on. Yeah, that's how I understand the question.
Yes, same.
Yes.
Yeah. So you can customize out the data styles according to the underlying model. You can visualize, of course, if the data bites to a certain model. But if you're talking about changing the model, no, that is not what GeoNode. It is not GeoNode purposes. I'm also working on integrating GeoNode with GeoServer and GeoFence, but I have encountered some errors during the process. Can you provide guidance on best practices of common pitfalls to avoid this integration? Well, that's a very broad question, and it goes a little bit aside from the GeoNode topic. So I recommend you could write an email to the support team in GeoSolutions. There are the links that will be shared in the presentation. Because I hope you understand that some errors, it's a bit too general. GeoFence, I can share with you the general documentation that we have for GeoFence, for GeoServer. But let's say that this topic is more related to GeoServer rather than GeoServers rather than GeoNode. But one thing is that it's worthwhile to say is I would recommend you would follow the tutorial, that you can see from the documentation I'm sharing. GeoNode it has its own authentication and authorization model that pertains only to GeoNode and can also be propagated to GeoServer. But GeoFence, it is something that is kind of behind GeoNode, let's say. It operates more at a low level or at GeoServer level. And of course, offers a more fine grain and granular settings to data access and data authorization. But again, GeoFence, it's not to confuse people. It's totally another tool. It's specifically designed for authentication and authorization of data in GeoCenter. Okay. So I see no more questions at the moment. In any case, these slides of this webinar will be shared. At the end of my presentation, there are the contacts you can reach out to in case you have more questions, technical questions about GeoNode. So if you want, we can talk about support and how we can support your activities in case you are using open source products, not just GeoNode, GeoServer, Monster, and all the others source geospatial products. Okay, so Angelo and Katia, I don't see any other questions that has come by. So I would close this webinar. Thank you all for attending. I hope you found that useful. To say again, recordings and slides will be shared in our GeoSolutions blog. In there, you will be able to review the session again, the slides again, and all the contacts that you may need to get in touch with GeoSolutions. Thank you so much. Have a great afternoon, morning to everyone who attended, and I'll see you at the next webinars. Thank you.
Thank you, everyone. Thank you, Alessandro.
Thank you very much,
Angelo.
everyone.
Thank you, Katia.
Bye-bye.
Bye.